Welcome to another session of Ebenezer coaching classes. This is a numerical aptitude type problem for 2 marks. The characteristic equation of a unity negative feedback system is 1 plus k GFS is 0. The open loop transfer function GFS has one pole at 0 and two poles at -1. The root locus of the system for varying k is shown in the figure. The constant damping ratio line for zeta equal to 0.5 intersects the root locus at a point A. The distance from the origin to point A is given as 0.5. The value of k at point A is dash. Now, we should know what a root locus diagram is. A root locus diagram is the path taken by the roots of the characteristic equation when you change the value of k. So 1 plus k GFS equal to 0 will have roots, and the path taken by the roots is drawn by the root locus diagram. Now, let us, for example, take a standard second order characteristic equation, s square plus 2 zeta omega n s plus omega n squared equal to 0. So its roots will be the roots of the quadratic equation. We know that s is equal to minus b minus 2 zeta omega n plus or minus root of b squared 4 zeta squared omega squared minus 4 omega n squared by 2 into 1. So we bring 4 outside and we bring minus 1 outside. This becomes minus 2 zeta omega n plus or minus root of minus 4 and bringing outside. Inside will become omega n squared minus omega n squared zeta squared by 2. So this is minus 2 zeta omega n plus or minus 2j. Root of minus 4 is 2j. Omega n squared I take common, 1 minus zeta squared. So 2 gets cancelled, minus zeta omega n plus or minus j omega n times root of 1 minus zeta squared. Now this is the root of this characteristic equation. So there are two values here, minus zeta omega n plus j omega n root of 1 minus zeta squared. Other one is minus zeta omega n minus j times omega n root of 1 minus zeta squared. Now, what do we observe from these two roots? We know that the distance from the origin. How will you find the distance from the origin? It is, suppose you have a root. Suppose you have a root a plus jb. So the distance from the origin of this root will be root of a squared plus b squared. It's very obvious. So if we have this point is, if this point represents a plus b, then this is a and this is b, and this distance is root of a square plus b square. This distance is root of a square plus b square. Now let us see what is the distance here. Real part is minus theta omega n. Imaginary part is plus or minus j omega n root of 1 minus theta square. Let us find out what is the distance from the origin. It is minus r square. Distance from r squared is theta square omega n square plus omega n squared into 1 minus zeta squared. So this is zeta squared omega n squared plus omega n squared minus zeta squared omega n squared. So this is omega n squared. So r is omega n. So distance from the origin of the root is omega n. And what is the angle? Angle is tan inverse of b by a, which is tan inverse of root of 1 minus zeta square by c. Or in other words, let's say the angle is theta. Theta is tan inverse of b by a. Or we say cos theta will be a by root of a squared plus b squared. In this case, a is zeta omega n divided by omega n or plus theta. So z cos of cos theta is theta. And sin theta is root of 1 minus zeta squared. Now, knowing these properties, now let us find out what they are asking. Now they are asking and they are saying that zeta is 0.5. This line is zeta is 0.5 and it meets at this point, and we know that from the distance of this root from is omega n. Okay. So this distance is 0.5 and the angle, this angle theta, cos theta is theta, which is given as 0.5. So theta in this case is pi by 3. So this point, if this is the pi by 3, this angle from the positive x-axis is, let me call it phi, is pi minus pi by 3, or it is 2 pi by 3. This angle is 2 pi by 3. Now this angle is 2 pi by 3. So this point can be represented by, if you have magnitude as r and the angle as theta, then the point can be represented by r e power j theta. Now r is 0.5 and theta is 2 pi by 3. So the root at the top is going to be let me call s is equal to 0.5 e power j 2 pi by 3, and at the bottom it's going to be 0.5 e power minus j 2 pi by 3. So this is going to be 0.5 cos 2 pi by 3 plus j sin 2 pi by 3. Cos 2 pi by 3 is same as minus cos pi by 3. Minus cos pi by 3 is minus half. And sin 2 pi by 3 is same as sin pi by 3. Sin pi by 3 is root 3 by 2. J root 3 by 2. So this is going to be minus 1 by 4 plus j root 3 by 4. Now, the open loop transfer function has one pole at 0 and two poles at minus 1. So the open loop transfer function is T of s is 1 by s into s plus 1 the whole square. And the value of k is the magnitude of 1 by because 1 plus k g of s is 0. So k g of s is minus 1 and k is 1 minus 1 by g of s and k is positive, so k's magnitude will be so k is magnitude of minus 1 by g of s, or it is 1 by magnitude of g of s at all points. So s here is g of s is s into s 1 by s into s plus 1 the whole square. So k is magnitude of s into s plus 1 whole square. So we take one point, the point that we have mentioned here is s is equal to minus 1 by 4 plus j root 3 by 4. So put those values here. So let me write it here. Since I don't have space, let me draw a line here and write it here. K is going to be magnitude of s into magnitude of s plus 1 whole square. Magnitude of s at that point we already know is 0.5. Magnitude of s plus 1 will be magnitude of one plus minus 1 by 4 plus j root 3 by 4 whole square. So this is 0.5 magnitude of 3 by 4 plus j root 3 by 4 whole square. This is 0.5 times 9 by 16 plus 3 by 16. So this is 0.5 times 12 by 16. Or this is 0.5 into 12 is 6 by 16, or plus 3 by 8, which is 0.37. So the answer to the problem is 0.37. 0.37. Thank you. God bless you.